We are going to now see how to use Cramer's rule to solve a linear system. And we have a linear system of 3 variables, and we have a coefficient matrix, which is a square matrix. So the first thing we need to do is to check that the determinant isn't 0, because that is a condition for us to use the Cramer's rule. And to find the determinant, we see that we can simplify the calculation a little bit, and we can use the last row over here multiplied by -2 and add to the second one. So what we have is that 0, 3, and 4, and we're going to have 0 over here, -2 times -2 plus 2 is 0, and then this is going to be +2 minus 1 is going to be 1, and this 2 over here is not going to be changed, and then this one is going to be still 1, -1, and 0. Okay. Now we're going to expand this determinant along the first column. Remember the signs, plus, minus, plus, so what we have over here is simply 1 and times, and the cofactor over here is 3, 2, 4, 1, this determinant. So now we have 6 minus 4 and is equal to 2. So the determinant is equal to 2, and that's good. Now let's first write down the solutions before we do the calculation. According to Cramer's rule, the first variable x is going to be equal to the determinant of a, which is the denominator, and then the numerator over here is going to be a determinant. What we do is that we use the vector b on the right hand side to replace the first column of a. So what we have over here is 2, 0, -2, and then just copy the rest of the coefficient matrix, 3, -1, -1, and 4, and 2, and 0. So that would be the value for x. And for y, we have a similar way to find its value. The determinant is always in the denominator, the coefficients determinant. And then in the numerator, because y is the second variable, so we replace the second column by the 2 over here, 0, and -2. Look at the coefficient matrix, and we copy the rest of the columns, 0, and 2, and 1, and 4, and 2, and 0. Okay, so do the same thing for z, and then we have determinant of a, and here now z is the last variable, so we're going to replace the last column by 2, 0, -2, and the other 2 columns we copy them over here. Okay, so now the rest of the calculation is just to find values of these 3 determinants, and we will do the calculation over here just as a practice, and 2, 3, 4, 0, -1, 2, and -2, -1, 0. Okay. We can add the last row to the first one, so we're going to have equal to 0 over here, and 2, and 4, and then 0, -1, 2, and then -2, -1, 0. So we add the last row to the first. You may say, why don't you add the first row to the last? That is just going to be the same. And then we have -2, use cofactor expansion along the first column, then we have 2, 4, and -1 and 2. So that will give -2, and we have -4 and 4 minus negative 4, so we have plus 4 over here, and then we have negative 16. Okay. And we do the same thing and calculate the determinant for the numerator of y, and then we have over here 0, 2, 1, and 2, 0, negative 2, 4, 2, and 0. Okay. So let's add now the first row to the last row. Then we have 0, 2, 4, and 2, 0, 2, and 0 plus 1 is going to be 1, 2 plus negative 2 is 0, and this is going to be 4. Okay. This is actually a determinant. We are trying to find the determinant. Okay. And then we can use now the second column to expand it. Remember the negative sign in this cofactor. So what do we have over here is negative 2, and then we have 2, 2, and 1, and 4. And then we have negative 2, and we have 8 minus 2, that's 6. And then we have negative 12. Okay. All right. So we can now find the last determinant, 0, 2, 1, and 3, negative 1, negative 1, 2, 0, negative 2. Okay. We do the same thing. Add the first row to the last row. Then we have 0, 3, 2, and 2, negative 1, 0. And then we have 1, and 2, and 0. Okay. So now we expand along the last column. So what we have over here is that we have 2 times 2, negative 1, 1, 2. And that will give us 2. And this is 4 plus 1, which is 5. And then we have 10. Okay. So eventually we have the following solution, that x is equal to negative 16 over 2, and that's going to be negative 8. And y is negative 12 over 2, and that's negative 6. And z is equal to 10 over 2, and that's going to be 5. All right, that's all for this Cramer's rule.